Okay, hello students. Today, actually, I am discussing about few carbohydrate metabolic pathways. So, okay, so actually, I do have network issues. So, I thought that this will be very useful way of communicating with you. So, I am making a small videos of this glycolysis. Sorry, this carbohydrate metabolic pathways. Okay. Okay, first we'll start with the glycolysis pathway. As we know that the starting material for this glycolysis pathway is glucose. Glucose. So how this glucose is produced? So we know there are many pathways where the glucose can be produced, where this glucose can be produced. Okay, one maybe the glycogenolysis pathway, and another one maybe the gluconeogenesis pathway. Okay. As a result, the glycogen can be broken into the glucose, and by lactic acid or glycerol, and many keto acids also can produce the glucose, as we have discussed in the previous lectures. So with the help of that, I am telling you that the glucose can be produced either by glycogen or many other sources like lactic acid or amino acids. By this way also we can produce. So when a glucose is produced from the glycogen, it is called as glycogenolysis, and if it is produced from other sources like lactic acid, then that process is called gluconeogenesis. As we already know that this glucose molecule is a hydrophilic moiety, that is, it is water soluble, but when we see the cell membrane, it is hydrophobic or lipophilic moiety. Okay, it is a lipophilic moiety. So to cross these hydrophilic substances into the cell membrane, as the cell membrane is lipophilic, one should help the glucose to enter into the cell. So that is called actually glut receptors or gut transporters. We know that glut is nothing but GLU is glucose, and T is nothing but transporter. Okay. In different organs there will be different type of glut transporters. For example, if you talk about the liver, so liver in the liver cells, cell membrane will have GLUT2 receptors. Okay, with the help of this glut receptors only, the glucose will enter into the cell membrane. Then other process will start. Okay, so this is the starting material for glycolysis pathway. So the glucose will enter into the cell membrane. Okay. In the same way, the glut receptor can also facilitate the glucose to exit out of the cell membrane. Okay, to avoid this process, okay, the glucose immediately should convert into another intermediate, that is called glucose 6-phosphate. Okay, how this glucose convert into the glucose 6-phosphate? Actually, glucose will be added to the phosphate group at the 6th carbon. This how this from where this phosphate group came. Okay. this this step will be facilitated by the enzyme, like there is hexokinase or glucokinase. Okay, kinase is nothing but it is nothing but addition of the phosphate group. From where it is adding, this kinase will take the this phosphate from the ATP. So the ATP will be converted to the ADP, and actually when the ATP, that is adenosine triphosphate, a 3-phosphate, is converting to adenosine diphosphate, that is 2-phosphate, one of the phosphate will be liberated. Okay, this phosphate will be added to the glucose, so it will be converted to the glucose 6-phosphate. Okay, next step is that glucose 6-phosphate will be converted to fructose 6-phosphate. Glucose will be converted to fructose. Okay. So glucose and fructose, those are called isomers, right? So isomerization, this step is nothing but isomerization. Okay, glucose is six-membered intermediate, and fructose is 6-membered intermediate, and these two are isomers because glucose is aldehyde and fructose is ketone. Okay, so this is isomerization step. So the enzyme involved here is phosphohexo or phosphofructo isomerase. Okay, hexo means 6 member, so it is converting to the fructose, so we can call it as a phosphofructoisomerase or phosphohexoisomerase. Okay, from fructose 6 phosphate it will be converted to fructose 1,6 bisphosphate. Actually one more phosphate group is adding. Okay, we already have seen in this first step that glucose is converting to glucose 6 phosphate, so kinase enzyme will be involved. And where the ATP is coming, ATP is coming from the from where the phosphate group is coming, the phosphate group is coming from the ATP. So here also one more kinase enzyme should be involved. So here actually we will use an enzyme that is called phosphofructokinase enzyme. In short we will call it as PFK. It is actually phosphofructokinase 1. Okay, this kinase will take the phosphate group from ATP, and the ATP will be converted to ADP. So here in these steps 2 ATPs will be utilized. Okay, 2 ATPs will be utilized. Okay, finally the fructose 6 phosphate will be converted to fructose 1,6 bisphosphate. Okay, here from up to here it is clear, I think. Okay, then the real steps will start. The fructose 1,6 bisphosphate, actually this is a 6 member, so this will be splitted into 2-3 carbon sugars. Okay, there actually one enzyme will be used that is called aldolase. Okay, aldolase means what? That will break down the fructose into 3 carbon moieties. One will be dihydroxyacetone phosphate, one will be one will be dihydroxyacetone phosphate, the another will be glyceraldehyde 3 phosphate. Okay, dihydroxyacetone phosphate is a 3-membered sugar which contains ketone group, and glyceraldehyde 3 phosphate is a 3-membered ring which contains aldehyde group. Okay, this fructose will be splitted into 3 carbon sugars by using the enzyme that is called aldolase, right? So in this actually that dihydroxyacetone phosphate will also convert into glyceraldehyde 3 phosphate. So actually dihydroxyacetone is nothing but ketone, and glyceraldehyde 3 phosphate is aldehyde. So this ketone is converting to the aldehyde, so this step is nothing but isomerase. Since it is a 3 carbon sugars, so there will be a triose there. Here actually in the second step there is a 6-membered ring, 6-membered carbons are converting. That means one group is converting to another group. There is aldehyde is converting to ketone. Here actually 3 carbon sugars are converting. So there we have used hexoisomerase. Here we have to use triose isomerase. Okay, so so we will use the enzyme that is triose phosphoisomerase to convert the dihydroxyacetone phosphate to glyceraldehyde 3 phosphate. Okay, then this glyceraldehyde 3 phosphate, then these pathways are very simple. Actually up to here, from up to this fructose 1,6 bisphosphate, these units are single units, one subunit is forming. So here actually this dihydroxyacetone phosphate also converting to glyceraldehyde 3 phosphate. So here actually 2 glyceraldehyde 3 phosphates are there. So whatever the intermediates forming from this GA3P, those intermediates are we have to consider it as a 2 units. Okay, for example this GA3P, that is glyceraldehyde 3 phosphate, is converting to 1,3 bisphosphoglyceride, means it forms a 2,1,3 bisphosphoglycerides. Okay, it is not single unit this is not single 1,3 bisphosphoglyceride. Those are 2,1,3 bisphosphoglycerides. Remaining steps also we have to consider it as a double. Okay, now in the next step the glyceraldehyde 3 phosphate is converting into 1,3 bisphosphoglyceride. Actually here we are going to use one very important enzyme, that is glyceraldehyde 3 phosphate dehydrogenase. Remember students, whenever you talk about an enzyme that is dehydrogenase, Okay, we have to we have to keep one thing in our in the mind, that actually NADP plus is converting to NADH, or NADP plus is converting to NADPH, or FAD plus is converting to FADH2. Okay, this is actually these steps are nothing but those are getting reduced. Okay, whenever you are talking about dehydrogenase, the particular enzyme is removing the hydrates from the substrate, and it is adding to either it is to adding to the NAD plus, or it is adding to FAD, or it is adding to NADP plus. Okay, so excuse me. So here in this step, this glyceraldehyde 3-phosphate dehydrogenase is taking the hydrate from glyceraldehyde 3-phosphate, and it is adding to NAD plus. Okay, and it is converting to NADH. Okay, and one more thing, this enzyme has a property to add inorganic phosphate to the substrates like glyceraldehyde 3-phosphate. So if the glyceraldehyde 3-phosphate it get one more inorganic phosphate, we will get a product called that is 1,3-bis phosphoglycerate. Okay, remember, it is not bi, it is a bis. Bis means actually the phosphate the carbon with the phosphate groups, there is a distance, so they are not immediately attached. Okay, for example, there are 6 carbons as for example there are 3 carbons, so these phosphate groups are not attached to 1 and 2 carbons. The phosphate group is attached to 1 and 3 group 3 carbons, so there is a gap, there is 1 carbon without phosphate, so it is not continuous, there will be gap. Then if the gap is present, this then we have to call it as a bis. It is not di or bi. Okay, if it is a bi, so the phosphate group should present continuously, it should present in 1 and 2 carbons. If there is a gap and it is not continuous, it is called bis. So the product formed, it is 1,3-bis phosphoglycerates. 2 phosphate group containing carbons are not continuous. Okay, next step. Okay, next step. I am repeating one more time here. Actually, what we are talking, actually, that dihydroxy, that fructose 1,6-bis phosphate will be splitted into dihydroxyacetone phosphate and glyceraldehyde 3-phosphate. Again, this dihydroxyacetone phosphate will be converted to glyceraldehyde 3-phosphate by using the enzyme that is called triose phosphoisomerase, because this is isomerase reaction. Okay, next, the glyceraldehyde 3-phosphate with the help of glyceraldehyde 3-phosphate dehydrogenase, it will be converted into 1,3-bis phosphoglycerate. Okay, here in the next step, this 1,3-bis phosphoglycerate will be converted to 3-phosphoglycerate. So here, when we see the difference, actually here in the this substrate 2 phosphate groups are there, and here in this step, in this product, only 1 phosphate group is there. So it is releasing the phosphate group, that means it is donating to whom. So in the previous steps we have ADPs, right? That ADP will utilize this phosphate group, and ADP will be converted to the ATPs. So we already know that glyceraldehyde 3-phosphate is not 1, it is 2. So here also ADPs is not 1, so it is 2 ADPs, and we will get 2 ATPs. Okay, since it is also adding a phosphate group, so there will be kinase enzyme. So here the enzyme is phosphoglycerate kinase. Okay, since the previous intermediate is phosphoglycerate, so we will use that name, that is phosphoglycerate kinase. Okay, next step, actually this 3-phosphoglycerate is converting to 2-phosphoglycerate. So here actually at the 3rd carbon, whatever the phosphate group is there, it is shifting to the 2 carbon, second carbon, so it is called mutation. Okay, so if 3-phosphoglycerate is converting to some other 3 product, then that will not be called as mutation, but here some mutation is happening. Whatever the phosphate group present in the second, it is shifting to the whatever the phosphate group is present in the thorn, it is shifting to the second group, so we will call it as a mutation. So what is that mutation? So it is a phosphoglycerate, so we will call it as phosphoglycerate mutase enzyme. Okay, next step, this 2-phosphoglycerate will be converted into phosphoenol pyruvate. So remember guys, actually this is a enol. Okay, enol means what? It is an alcohol derivative. Okay, it is an alcohol type of thing. So it is an alcohol type of thing. So so it this 2-phosphoglycerate is converting to enol. So the enzyme whichever is facilitating, that is called enolase. Okay, it is helping to convert this 2-phosphoglycerate to enol containing intermediate, that is called phosphoenol pyruvate. Okay, phosphoenol pyruvate. So next step in this phosphoenol pyruvate will be converted into the pyruvate. So here actually we have to remove again what? Phosphate group. So which enzyme it will use? Kinase enzyme. Which kinase? Actually this is a phosphoenol pyruvate, so it is forming pyruvate. We will use the name pyruvate here, pyruvate kinase. Okay, up to here the formation the glucose is converting to pyruvate. This is called glycolysis pathway. Okay, what will be the fate of the pyruvate? Remember guys, when the oxygen is present in the cells, the pyruvate will follow aerobic conditions, aerobic type of reactions. So in the presence of oxygen, the pyruvate will be converted to acetyl CoA. Okay, this acetyl CoA will enter into the Krebs cycle. So I am talking about this. Okay, when there is what? Oxygen, high amount of oxygen or sufficient amount of oxygen, the pyruvate will be converted into the acetyl CoA. Okay, if there is no oxygen, that is called anaerobic conditions, the pyruvate will convert into a one product that is called lactic acid, which is present in the muscle cells, especially maximum in muscle cells, and from the muscle cells the liver will take this lactic acid and will be stored. Okay, so the pyruvate will convert into lactic acid with the help of enzyme that is lactic dehydrogenase enzymes. Remember guys, it is a dehydrogenase enzyme, so it will facilitate that NAD plus to NADH. So I did not written that one. So generally that if you get dehydrogenase steps, so NAD plus will convert to NADH, or FAD will be converted to FADH2, or NADP plus will convert it to NADPH. Okay, remember guys, one more very important thing here. What is that? Actually this lactate dehydrogenase enzyme, if it is very highly generated, so remember this is a disease condition. Okay, so for example, when in our body the oxygen level is very low, so the oxygen supply is not very good to the cells, so the cells start to producing lactic acid more, and the lactic dehydrogenase enzyme will be more. So whenever in any patients in any person the lactic dehydrogenase enzyme is very high, you have to imagine, you have to understand the person is suffering with a low oxygen level. So ultimately we can conclude that the person is suffering from hypoxia. Okay, so this condition will lead to cardiac diseases like ischemia and cardiovascular type of diseases. Okay, thank you guys. This is about glycolysis pathway. And one more important thing, actually I need to discuss a shortcut how to remember this glycolysis pathway. See, you have to remember some sentence here. Okay, you have to remember the sentence. Please don't write in the exams here. You in the exam these sentences please remember and you can easily catch up the intermediates and what are the enzymes used in the glycolysis pathway. So for example, when we see, I'm sorry, okay. Okay, so there is one sentence. So a great grandmother is there. She is actually throwing some fresh fruit dishes. So throwing some fresh fruit dishes, and she is picking pumpkins to prepare what? Pies. Okay, so you are present in your grandmother's home. She is preparing what, pumpkin pies. So by throwing what, fresh fruit dishes. So by seeing that, when you are talking by phone, so you will keep that phone and we will take a plastic plate and you will eat that pies. Okay, that's what the sentence you have to remember. So here actually, remember the sentence: a great grandma throws what, fresh fruit dish and go by picking pumpkins. Okay, for what she is picking pumpkins? To prepare pies. Okay, she want to prepare pie by throwing what, fresh fruit dishes. So how she will prepare the pies? She has to pick the pumpkins. Okay, pumpkins. Next thing is that, so when you know, you like, after seeing that she is preparing what, she is preparing the pumpkins, so what you will do, you put the phone. So why, when like, if you are talking by phone also, you'll put the phone and we will try to take the plate. You'll try to take what, plate? You will try to take the plastic plate. What is that plate? Plastic plate to eat the pie. So remember guys, here great, Z, actually G is what? So to remember the intermediates, so you have to remember this: great grandma throws the fresh fruit dish and go by picking pumpkin to prepare fresh pies. Okay, okay. So great is nothing but glucose. Grandmother, so that is a second product. Glucose is converting to the glucose 6 phosphate. So throws T, don't remember that, like, you leave that one. Next, fruit, F, that is fructose 6 phosphate. So another F, that is fructose 1,6 bis phosphate. So dish, die. The fructose 1,6 phosphate, with the help of aldolase enzyme, that will be broken into 3 carbon sugars, that is, one is dihydroxystrone phosphate, dish, D. Okay, and and is what, and so and we don't remember. So next one is dihydroxystrone phosphate. One more is that glyceraldehyde 3 phosphate. Okay, so after the glyceraldehyde 3 phosphate, that is bis. Okay, bis, that is 1,3 bis phosphoglycerate, that is bi. So picking is nothing but 3 phosphoglycerate. Next, 2 phosphoglycerate. 1 P is phosphoglycerate, 3 phosphoglycerate. Another P is 2 phosphoglycerate. That phosphoglycerate will convert into phosphoenol pyruvate with the help of enolase enzyme. Next, the phosphoenol pyruvate with the help of kinase, that is pyruvate kinase, it will convert into pyruvate. Okay. Next, to remember the enzymes, so H is nothing but what, ma? That is hexokinase. Next one is put, P is nothing but what? Either it is phosphohexokinase or isomerase. So here actually that glucose 6 phosphate will convert into fructose 6 phosphate, so it is isomerase. It is phosphohexoisomerase or phosphofructoisomerase, either. So next, it is isomerase. Then we will need one more kinase, that is phone, P, that is phosphofructokinase 1. Next, splitting, so it which enzyme? Aldolase enzyme. Next, isomerase again, that is T, triose phosphoisomerase. Next one, D, glyceraldehyde 3 phosphate dehydrogenase, where the glyceraldehyde 3 phosphate will be converted into bis phosphoglycerate, that is 1,3 bis phosphoglycerate. Then the 1,3 bis phosphoglycerate, with the help of kinase enzyme, it will remove one phosphate group, this phosphoglycerate kinase. Next, mutation, so phosphoglycerate mutation. So next one is enolase. Next, P, pyruvate kinase. Okay, that pyruvate kinase, it was at last forms what it at last forms pyruvate. Up to here, this is the glycolysis pathway. Thank you very much.